Jai Hind everyone, myself Ankita, Faculty Department of IT, AKGEC. Today I am going to discuss Unit 2 Hadoop from the course Big Data. Course code is KOE 097. Now the content I am going to discuss is Introduction to Hadoop, Features of Hadoop, Advantages and Disadvantages of Hadoop, and finally the components of Hadoop. Now what is Hadoop? Hadoop is the solution to big data problems. So what exactly is big data? So we have in the last video lecture, we have discussed what is big data. So big data refers to extremely large data sets which are difficult to manage by traditional data processing tools. So we are having large amount of data that is being generated every day through social media website or the mobile phones. Now if we want to use that big data for our interest, we should be able to store that data as well as we should be able to analyze that data. Now that is the problem of your big data, that we should be able to store the data and analyze the data. Now to store and analyze the data, the Hadoop has provided you the solution. So Hadoop is basically an open source software developed as a project by Apache Software Foundation. So it was a software that is that belongs to Apache, and Apache Hadoop software library. The definition of Apache Hadoop is that Apache Hadoop software library is a framework that allows for the distributed processing of large data sets across the clusters of computers using simple programming models. Now this definition is, will look difficult, but it's not. So in your Hadoop, we are storing the data in a distributed manner across various commodity hardware. So we're not storing the data at one server, rather we are distributing the data, dividing the data and distributing in the various commodity hardware, and then we are doing the parallel processing of those data across those commodity hardware. So basically Hadoop has provided you a framework which allows you to distribute the data across various commodity hardware and also process them parallelly. So dog cutting started the Hadoop in 2008 and Yahoo donated. It was initially a Yahoo project that it was donated by Yahoo to Apache. In 2011, we have the first stable version, that is Hadoop 1.0. In 2013, we have the Hadoop 2.0, the stable version, and today we are at Hadoop 3.4 in 2024. Now in Hadoop 3, we have various features, that is enhanced yarn and support for multiple name nodes. Also Hadoop comes in various flavors, or we can say distribution. So if we are working on Hadoop, we are on the cloud, so we use Cloudera flavor. Other than we have IBM Big Insights and MapReduce. So these are various flavors, or we can say distribution of Hadoop according to our use case. Next is Hadoop ecosystem also has expanded into various other tools, that is Apache Spark and Flink. So they are advanced version of your Apache Hadoop. Now let's try to understand about Hadoop by studying the features. First is Hadoop is open source. Now Hadoop is open source. It means that the source code is freely available. We can inspect, we can modify, we can use them for our use case. So it is an open source software provided by your Apache Software Foundation. Hadoop cluster is highly scalable. Now scalable means that as and when requirement increases, is my system is able to accommodate that change or not? That is your scalability. Now in your previous data processing systems, where we have the relational database, where we are storing the data at one server, we have the option of vertical scalability. So as my data size increases, we have to increase the capacity of my server. So that is your vertical scalability. Now it is always expensive for me because I have to increase the capacity of my server. So it is expensive. The solution to that is your horizontal scalability. So what we do in horizontal scalability is, since in Hadoop we are storing the data across various different machines, if the size of data increases, so we can add on more machines. That is your horizontal scalables. So we can add on more number of nodes, and that is called as horizontal scalability. So Hadoop offers you both horizontal as well vertical scalability, therefore it's called as highly scalable. Now Hadoop also provide fault tolerance, means we are storing the data, we are first dividing the data and storing in the different nodes. Now we're not storing one data block at one node. We are storing it across multiple nodes. So suppose we have a data, okay. Now we have a data and we are dividing these data into 3 chunks. We are storing it at one machine, and with that we are replicating this block across various machines. So this is known as the function of replication. So by default, Hadoop have the replication factor of 3. So any data block will be stored at 3 nodes, right? So that is your replication. So Hadoop 3 has replaced this replication mechanism by eraser coding. Now obviously when you were storing the same data block across 3 nodes, we are wasting our space. So to prevent that, we have a new concept of erasure coding, in which we are, with the help of complex algorithms, we are finding out the parity. So if any other block get deleted, with the help of parity functions, we are able to retrieve that block again. So that is your fault tolerance. So it means even if the fault arises, the Hadoop is able to recover from that fault. Hadoop provide high availability because it's a byproduct of fault tolerance. Obviously, since the data is replicated across various nodes, the data will always be present. So if any other data nodes gets down, if any nodes get down, so we are still able to access that data. Next feature is Hadoop is cost effective. Since we are not storing the data on expensive server machines, we are storing the data on simple machines, or we can say commodity hardware. Our Hadoop solution to big data is very cost effective. Hadoop is faster in data processing. So here we are storing the data across various nodes. The processing is happening parallelly across these nodes. So therefore, data processing is faster. Data locality concept, it means that since the data is stored in various nodes. Now, when we have to manipulate this data, we're not moving this data across the network. We are just moving the logic to manipulate the data across these nodes. So, if we have to manipulate these data across 3 nodes, instead of moving the data to the processing server, we are moving the logic to each of these codes. So, obviously, the network bandwidth is less required. So this is all known as data locality concept. Hadoop provide feasibility. Obviously, we are able to manipulate the data, that which is unstructured, semi-structured, or structured. That means data is feasible. So let's summarize the advantages of Hadoop. First, it is cost effective. We have discussed why, because we are storing the data on the cheap commodity hardware, as and when need arises, we can increase the number of commodity hardware. Scalability. So this is a byproduct of when it's horizontal scalable as well as vertical scalable. Flexibility, it can store the data in the video format, in the text format, anyway. Speed, since we have data locality concept, the speed, there is no network cost. Therefore, the speed of manipulations increases. Also, the manipulations happens parallelly across various nodes. Fault tolerance, since the Hadoop provide you the features of replication, so obviously our system is fault tolerant. High throughput and minimum traffic, network traffic is just a byproduct when we are storing the data across various nodes, processing the data parallelly, and as well as moving the logic on these nodes rather than the data itself. So that is your advantages of Hadoop. Disadvantage, the major disadvantage of Hadoop is that it is very difficult to access the data of small size. Now in your Hadoop, we are dividing the data in the form of blocks. Now the minimum size of a block is 128 MB. Now if my file size is less than 128 MB, I won't be able to use Hadoop. So that's a problem of small data files, small data surrounding, as well as high processing. All these are difficult to do on your small data files. Vulnerability, because the Hadoop is basically written in Java, it is more vulnerable to the to the attackers. We can attack the Hadoop. Security, the Hadoop doesn't have any inbuilt security feature. It is using Kerberos, so it is very difficult to manipulate that Kerberos for your security feature. Batch processing, so there is no real-time processing in your Hadoop. Rather, we have some flavors which allows you the stream processing, but in Hadoop original we don't have the real-time processing features. Is your components of Hadoop. So Hadoop basically have master-slave topology. It means we have a master node and we have multiple data nodes. Now, as an example, suppose you are doing some, as a student, you are doing some projects under a guide. So we can say a guide is a master node, whereas you as a student is a slave node. Now, master node will assign the task to the slave node. It won't perform any functionality on its own. Computing is done by the data nodes only. So on the slave, so main computation happens in your slave nodes, whereas the task is assigned by the master node. So in slave nodes we have the real data, whereas in master node we have the metadata. The metadata is data about the data. So where my data is being stored is all saved in your master node, whereas actual data is stored in the slave nodes. Now the components of Hadoop. Now in components of Hadoop, you can see these are the 1, 2, 3, 4 major components of Hadoop is there. First is your MapReduce, which is provide the processing ability to the data, whereas in HDFS provide you how we are storing the data across various nodes, whereas Yarn is just you can say as an OS, it will help you to manage the functionality, whereas common utilities are just an add-ons to help the proper processing in Hadoop. Now first we'll do what study about Hadoop. Now Hadoop HDFS, that is Hadoop Distributed File System. Now as I have told you, in Hadoop we are storing the data across various nodes. Now there are main two tasks that a Hadoop is doing. First, storing the data across various nodes, that is done by taken care by your HDFS. Second is manipulating the data parallelly across these nodes, that is done by your MapReduce. So first we are going to discuss about HDFS or Hadoop Distributed File System, in which we are storing the data across multiple commodity hardware. So as discussed, since we are storing the data across multiple hardware and also replicating the data, the system is highly fault tolerant. If any error occur, if any data nodes get down, we have other data nodes which are having the same data. Also, it provides high throughput access to application data in suitable for applications having large data set. So basically Hadoop enables to use commodity hardware which will help you to spend less money, because if my size of data increases, we can increase the number of commodity machines. Now as discussed, Hadoop will have two things, master nodes and the slave nodes. So master and slave nodes forms the HDFS cluster. The name node is called as the master node. So the master node that we were talking about in HDFS, the master node is your name node, whereas the data nodes are the slave nodes. Where the data is actually stored, it is stored in the data nodes. And suppose we have a data that has came to the master node. What the master node will do, it will divide the data into multiple chunks and save it in the various data nodes. It will also keep a note that which block is present at which data node. So that is your functionality of name node, right? So you can see the data is being distributed across various nodes. 300 MB data we are distributed across 3 data nodes, that is 128 MB each. Also, each data node read, write and process the data. Also, they send signals known as heartbeats. So how come my name node will know if any of the data node is not responding or has get down? In such cases, what happens? Every few minutes, a data node send a heartbeat to the name node to tell that yes, I am working. So if after some regular interval, any of the data nodes has get down and it won't be able to send the heartbeat to the name node. So name node will automatically come to know that yes, this data node is not functioning properly, right? So that is a functionality of your heartbeat. Now you can see we have a name node which have a 30 TB file. It has divided into 120 MB each. The blocks, it has divided a 30 TB file into various blocks, and each size of each block is 128 MB. That's default by HDFS. Okay? And then these blocks are being distributed across various data nodes. You can also observe that each data node is replicated across the data nodes, right? So the 30 TB of data is loaded into name node. The name node distribute it across the data nodes, and this data is replicated among the data nodes, right? So you can see the replication is performed at the 3 times. Suppose we have this data and we have replicated across these 3 data nodes. Okay, so that was your HDFS. Second is your MapReduce. Now we have stored the data in parallel in a distributed manner across various commodity hardware through your HDFS systems, where we have data nodes and the name nodes. Now we need to manipulate that data, and to manipulate that data in a parallel way, we use the concept of MapReduce. So MapReduce is a parallel programming model for writing distributed applications for efficient processing of large amount of data. So basically, MapReduce is the processing unit of Hadoop. So a processing is done at the slave node and the final result is sent to the master node. So जो भी processing होती है, that will happen in your slave nodes. So a data containing code is used to process the entire data. This coded data is usually very small in comparison. So this paragraphs tell you about the data locality concept. That is, if my data is distributed across various data nodes and I need to manipulate that data. So instead of bringing the data to a common place, right, to bringing a data to common place to manipulate, what I do, I transfer my logic to all these of 3 machines. So processing happens at these nodes only. So example of MapReduce is through this. So input, suppose I have bus, car, train, ship, train. So this is my input data. So the first step in your MapReduce is to split the data. So we have split the data into the different data blocks. Now, for example, bus, car, train, ship, train. In the map phase, what happens? I assign a key to all of these values. So this is 111, right? So these are my keys and this is the value. So the frequency of bus is 1, the car is 1, train is 1. Similarly, ship is 1, ship is 1. So like this, I am doing the map phase. In map phase, we are we are just bringing the data, a data block, into a key value pair. So we are transforming the split data into a key value pair. That is your map phase. Now after map phase, now this happens across various data nodes. Now what happens in the shuffle and sort, we are shuffling the data and bringing the same data with the same key at one place. So aim of this processing is I have to find out the frequency of each of these words. So according to my logic, I will do shuffle and sorting. So all the bus item has brought into 1 point, car as to 1 point, ship into 1 and train into 1. And after that, in the reduce phase, I will find out the final frequencies of all of these text. So in your this is your main functionality of your MapReduce, where we are trying to process the data, and the aim of processing the data is to find out the frequencies of these items, right? So in map phase, we are assigning, first in split phase, we are dividing the data across various multiple blocks, and in map phase, we are converting the data blocks into map key value pairs, and in shuffle and sort, we are shuffle and sorting according to what my logic is. So here my logic is to find out the frequency, so I will club the bus into 1 block, car into 1 block, ship into 1 block, train into 1 block, and the reduce phase, I will finally find out the frequency based on the key value pair. So that was your MapReduce function. Third part of your Hadoop is Hadoop Yarn. Now we have in Hadoop framework, we have Hadoop Common and Hadoop Yarn. Hadoop Common will have the Java libraries and utilities that is required by Hadoop modules. So these will consist of all the extra libraries that is required. Next important part is your Hadoop Yarn. So Hadoop Yarn is yet another resource negotiator. The full form of Yarn is yet another resource negotiator. It is a resource management unit of Hadoop, and it is available in Hadoop 2. In Hadoop 1, we don't have the concept of Yarn. In Hadoop 2, we have the concept of Yarn. So Hadoop Yarn is act as a OS to the Hadoop. It is a file system that is built on top of HDFS. So also it is responsible to manage all the cluster resources and job scheduling. So which data node will perform which manipulation, where the data will be stored, how the resources has to be managed. Earlier it was done by the name nodes. In Hadoop 2.0 it is done by Hadoop Yarn. So if any of the request for data manipulation or query is first come to your resource manager. Now again, this is your master slave architecture. This is your master node, whereas node managers are your slave, right? So any query that will come from client will go to resource manager, and each of the data nodes will have a node manager with them, which manages the nodes. Okay? And for each node, I will have a container which will have all the resources that is being possessed by that node. So each node will have two parts of yarn. First is your node manager and second is your container. So whenever a query will come, it will first come to the resource manager. Resource manager will ask app master to assign data nodes for the query. Now app master will then ask node manager to give out the resources that is kept in the container. So that is the application of your yarn.